All right, hi everyone. So I'm going to get started on my presentation now. So I'm Eloise Birchall from the Research School of Astronomy and Astrophysics at the Australian National University. And today I'm going to be talking to you about where stars, planets, and moons come from. So before I get into the talk, I just want to remind you a couple of things for how we're running the talk today. So because obviously this is online, please write your questions in the comments section on the Facebook live stream. And I'll probably be answering most questions at the end. But if I do see them during the talk, then I'll try to answer them, but I'll probably do them mostly at the end, so please be patient with that. I'll probably be talking for about half an hour. So my presentation is probably about half an hour, and then I'll spend some time answering the questions that you have then. So first I'm going to introduce, just checking that that was all of the things I needed to tell you, and I think it is. So I'm going to get started. So first I'm going to tell you, sorry. Okay, so I've already got a couple of questions and I will get to those, so bear with me a little moment. So I'm going to tell you a little bit about myself. So I'm a PhD student studying astronomy and astrophysics, and being a PhD student means that I'm learning how to be a researcher and that I'm studying space. Now I've already been at university studying astronomy for 9 years, and that's because there's a lot of stuff to learn and we still don't know it all, and that's where research comes in. So by researching we find out new things, and you know, we go to the edge of what we already know and then keep going and try to find out more things, and that's sort of what being a scientist is. So the Research School of Astronomy and Astrophysics is based at the Mount Stromlo Observatory in Canberra. So if you're joining us from Canberra, then that's you know, you might know where this is. Otherwise, it's in the Australian Capital Territory if you're joining us from elsewhere in Australia. So what does an astrophysicist do? So I want you to quickly have a little think about what you think an astrophysicist does, and then I'll go through and sort of tell you about that. So we study space. We do lots of research. We look at stars and planets and galaxies and black holes and all sorts of stuff that's in space. We use telescopes like this one that I've got back here, or ones that are much bigger, to look at space. And we also, this is particularly what I do, we teach computers the laws of the universe so that they can teach us how the universe works. Yeah, so my research is that I work on star and planet formation. And basically, the reason I work on star and planet formation is I want to know where the stars come from and where the planets come from. And I want to know where all the cool stuff that makes up the planets and that we find in meteorites, so rocks that fall from the sky, I want to know how that's made. And we already know lots about this stuff, but there's so many fine details, there's so many extra things we can learn, and so there's still a lot of new things to be discovered. Now, hopefully most people are familiar with the solar system, but if you aren't, let's just give it a quick run through. So the solar system is where the Earth lives, and you know, all the planets orbit the sun. So we've got Mercury is the closest to the sun, then Venus, then Earth, then Mars. And then we have the giant planets. We have Jupiter, Saturn, Uranus, and Neptune. Now, I see a little question there that someone's asked me what my favorite planet is, and it's actually Neptune, purely because I did a project on it when I was 10 and I quite liked it, and now it's my favorite planet. There are a couple of other questions there, but I will get to those throughout my talk. So that's basically what our solar system looks like, and we call that the solar system because all the planets go around the sun. So basically we have the planets orbiting the sun, and the sun doesn't move very much, And the sun is made up of gas and plasma, so it's very, very hot. And it uses hydrogen and helium. So it uses hydrogen, which is the first element. So, I've got a periodic table here. So it's the first element there. And it smashes atoms of that together to make helium. And that happens in the core of the sun, and that's why the sun is so hot. Now, how did we make the solar system? So you can think of this as kind of like a recipe. So, you can, to make things like a solar system, you can use a recipe just like you can when you make a cake. So the step one is going to be gathering the ingredients. So you get all your ingredients together, and then you make a star, and then you can make your planets, and then you get to enjoy your solar system. So I'm going to go through this in a little bit more details. So what do we need to make a star? Now, someone asked, how is the sun made? So I'm going to discuss this now when I discuss how stars are made. So the sun is a star, in case you didn't know that one yet. So the sun is actually a star, the same as all the stars that we see in the night sky, except it's just really close to us because we go around it. So that's why it looks so big. So to make up a star, you need lots of gas. So this is like hydrogen and helium, but you need lots and lots of it. Then you need a little bit of dust. So quite similar to the kind of stuff you find under your bed or that falls off your shoes when you come inside. You need it to be dense and cold. So basically you need a lot of stuff, and it needs to be quite cold, a lot colder than your freezer. It needs to be minus 263 degrees Celsius. That's very, very, very cold. And you need gravity. So gravity helps us a lot here because it helps pull everything together. So let's take a closer look at this little region here. So in a cold, dense place, the cloud collapses. So you've got the cloud, and so gravity starts pulling everything in. So it's pulling everything in, and as it pulls everything in, this is where the gravity is used. So it's pulling everything in, and it gets compacted and tighter and smushed up together. It gets nice and small. And this takes around 10,000 years. Now, once there's enough gas sort of smushed together in that ball, you get a baby star forming. It's kind of like when you are making a cake and your mixture just starts coming together. Now, we still add stuff onto the star, but stuff might fall out. So you can see these yellow lines in this picture that I have here. That's stuff that's getting thrown out of the star. The star doesn't want it. So instead of gobbling it up, it's chucking it away. And you can see all that sort of cloudy, dusty stuff that looks like it's falling onto the middle of that image, and that's the stuff that's falling onto the star. And this takes around 100,000 years. Now, this is my personal favourite stage of star formation because that's what I actually work on. So I'm going to try to show you a little video here, and we're looking from above and from the side for one of these baby stars. Now, hopefully you can see this. When we look at the side on one, you can see it throwing out stuff, and there's a bit of a whoosh happening. So I might play that again. And then when you're looking at it from above, you see sort of a flat disc forming. So I'm going to talk to you about that in a minute. But yeah, you can see that stuff that gets thrown out of the star and goes whoosh. So this is my research here, and I make these pictures using a supercomputer. So that's basically, it takes a week on something that's about as powerful as 50 laptops. So it takes a lot of computing power to make that. So now that we're up to, so as I mentioned, there's all this stuff that's falling onto the star. But if you've ever seen someone throw pizza dough, they start off with a ball, and as they throw it, it flattens out, and it becomes like a flat, pizza, like it becomes nice and flat. And so that's where you get these sort of discs around the planets. So this is what we can make planets out of. Sorry, around the star. You end up with this disc of stuff around the star, and that's what you can make planets out of. And it takes around 1 million years to get to this stage. Yes. So these disks are where planets can grow. So what I'm showing you here is actually an image that was taken with the Atacama Large Millimeter Array, which is a radio telescope in the Atacama Desert in Chile. And it's got these beautiful rings. Now, not every one of these rings will have a planet in it, but a few of them will. So this is what baby planets can do. This is where they can grow. They can act sort of almost as an ice cream scoop and scoop up all the material that's in their way and gobble it up and get bigger and bigger and bigger. So this might be a sign of that we're seeing planets growing. So basically we've already sort of made our star, and now we're going to try and build our planets. So that's the next step in building a solar system, because we've got our star, it's sort of forming in the middle, it's still going to gobble some stuff up, but you know, it's mostly there. Now planets grow by little bits of dust smashing together. So it grows by little bits of dust smashing together so that you, and then they stick together and they grow bigger and bigger and bigger. Now some stay small like asteroids. So, you know, the asteroids can be a few meters up to a few kilometers. So they can be quite big. And some keep growing and they get to be planet-sized, like our own planet, the Earth. Now, if we wanted to make a gas planet, what we do is we take this rocky core that we've made and we put it out past what we call the ice line. Now, what that means is if anyone's ever stood close to a campfire, you'll know that it's nice and warm when you're next to the campfire. But as you move away, it gets colder. So that's because, you know, near the heat source, it's warm, and as you move away, it gets colder. So the same thing happens with the sun. If you're close to the sun, it's very hot. But as you move further away, it gets colder and colder and colder. So things like water ice or other kinds of ice, like carbon dioxide or ammonia or methane ice, they can all survive further out from the sun. So these gas planets grow by gobbling up all those little ice bits and get bigger and bigger and bigger. And then you get your gas planets. Now, moving down another level, we get to the moons and trying to work out where they come from. So where do moons come from? So if we think about Mars, Mars's moons are both captured asteroids. So that's Deimos and Phobos. And so Mars's moons are just what happened with them, where they were a little asteroid and they went too close to Mars, and Mars was like, hello, I would like you as a friend. And they kept orbiting Mars, so now they're Mars's friends. So yeah, that's how Mars got its moons. Yes, so where do Jupiter's moons come from? So Jupiter's moons, so this is a photo that I took using just my phone camera and a telescope. I put it up to the eyepiece and tried to take a photo. So this is Jupiter and some of its moons. So Jupiter's moons came from sort of probably came from a similar environment to how the planets formed around the stars. You could have a disk around the baby planet and you could make moons out of there, or they just sort of were icy bodies that were made out there and came past. So someone asked how Titan was created, and so Titan was probably a sort of an icy block, and it just sort of grew bigger and bigger and bigger. And then, so Titan isn't one of the moons of Jupiter, it's one of the moons of Saturn, but similar process. So it got bigger and bigger until it was, you know, quite a big moon. And then it was just around Saturn. So now it's one of Saturn's friends. Yes, so we've got Jupiter here, and we've got its moons. So moving from Jupiter outwards, we've got Io, Europa, Callisto, and Ganymede. And Jupiter's moons, these 4 moons of Jupiter are called the Galilean moons. Jupiter actually has around 70 moons, but I just picked its 4 biggest ones here. All right, But where did our moon come from? So we start with our moon. So basically what we had was we had the baby Earth. So early Earth, it was a big lava ball situation. And we had an object that was about the size of Mars called Theia. Now, what happened with Theia was that it came past Earth and it came past a little bit too close and it actually hit it. And so you end up with material coming off from the baby Earth and Theia, and it sort of gets ejected, and then it ends up orbiting the planet, so baby Earth, and then it forms up into a moon. So where did our moon come from? It came from the same place as the Earth, which is the baby solar system. So, yeah. Now that's actually all of my content, but I can see that I've got quite a few questions that have come through, so I will try to answer some of those. So stars come from clouds of dust and gas, and the cloud contracts because of gravity and a star forms in the middle. So these clouds are then what the planets are made from. So when a star is born, there's lots of dust and gas around the star, and that's what the planets grow from. And the moons are made from the same stuff as planets, although they can be captured or form around the planet or form from a collision like our own. So I'm just going to have a look. So how was the sun made was covered in how stars are made, because the sun is a star. Feel free to write any additional questions you've got down. I'm just going through some of the ones that I've already got. So is the sun the biggest star? So no, the sun's actually quite a normal sized star. It's, well, the way astronomers measure it, it's one solar mass and one solar radius. But it's quite an average star. There's lots of stars that are a lot bigger, and there's plenty of stars that are a lot smaller. So the biggest stars, so let me just get this. So when stars are in the main part of their lives, that's what we call, astronomers call the main sequence. They just stay, a pretty constant size. And then as they get bigger and they get, so as they run out of fuel, they end up getting bigger, and these bigger stars are called red giants. So they end up being much larger than our star. I'm just going through the messages. Someone asked me who was the first person on the moon. And so let me just check if I have pictures from, I do have a picture from one of the Apollo missions. So the first person on the moon, that was during the Apollo 11 mission. So that's about 51 years ago now. So that's when they landed for the first time on the moon. So the first person on the moon from that mission was Neil Armstrong, and he was followed by Buzz Aldrin. Yes. Sorry, I've got a list of your questions here, so I'm just reading through them. So someone's asked, how long does an object have to orbit a planet before it's considered a moon? It needs to be captured, so it needs to not just sort of swing by and sort of leave again. It needs to be orbiting it properly. It can have an elliptical orbit, so it can, spend a lot of time out here and come back round, but as long as it comes back round, that's okay. And I think there might be a little bit of a size limit on moons. So if it's just we might refer to it as a satellite. If it's not, so like the satellites we have, but they're man-made satellites. So we can still refer to something as so moons are also referred to as satellites because they orbit a planet. sorry, I'm just reading through some of these. So how did the planets get their names? A lot of the planets, so a lot of the names that we have for the large planets in our solar system, so these ones. So Mercury, Venus, Mars, Jupiter, and Saturn are all easily visible with the naked eye, and they were known in ancient times. And so the names that they have are based on the names that they had in the ancient times when they were named after ancient deities. And then with Uranus and Neptune, they continued that pattern of naming them after ancient deities, and the same for Pluto. Pluto continued that pattern. And someone's asked, now I'm talking about Pluto, someone asked if Pluto has moons. Pluto does have moons. It has 4 or 5 moons. So Pluto has Charon, Hydra, Nix, Styx, and Kerberos. So I think that's 5. Yeah, and they're all slightly smaller than Pluto. So how were the dwarf planets formed? So the dwarf planets were formed in a very similar way to the rocky planets, but with ice. So out beyond Neptune, we have what's called the Kuiper Belt. So it's basically like an icy asteroid belt. So the asteroid belt lives between Mars and Jupiter. Now, so we have the icy asteroid belt called the Kuiper Belt, and that's where, so you'd end up with icy bits sticking together and growing into dwarf planet-sized objects. So that's how some of those dwarf planets out there formed. Someone has asked why Mercury is so dense. So Mercury is quite dense because it has a very large iron core. So compared to Earth, so Earth also has an iron core, but comparatively to the size of the planet, Mercury's is a larger percentage of the planet. So that's why it's quite dense. How it got that dense, I'm not 100% sure off the top of my head. So, sorry, I'm just reading through the questions. So where do asteroids come from? Asteroids are leftover bits from when we made our solar system. Is the Earth moon growing? How big can it become? So the moon is moving away from the Earth, and I'm not sure how long that will last, but it's moving very, very slow, and it has been for millions of years, billions of years, in fact. So don't be too worried about that. How big can a star get? Very, 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 very big. I'm not 100% sure off the top of my head, but when the sun decides to be a red giant, when it ends its life in 5 billion years, it will expand to out beyond Venus's orbit. So they can get millions of kilometers big. They're billions, no, maybe not billions of, no, they probably can get up to billions of kilometers big. They can be very, very, very big. What is the closest star to Earth? So the closest star to Earth is the sun, because the sun is a star. However, the next closest star, our next neighbour, is Proxima Centauri, which is about 4.5 light years away. So that's a distance of measurement. It's how far light travels in a year. So I have finished my talk now, and I am just moving through questions. And you've asked so many good ones. Are there other planets possible to live on? So in our solar system, the only one that we know of that could sustain life as we know it is Earth. However, one of the moons of Jupiter, sorry, I'm just getting to my Jupiter picture. So one of the moons of Jupiter, there we go. One of the moons of Jupiter, Europa, we think it has, well, we know it has a subsurface ocean. So there's ocean under the ice at the surface. And it's possible that that could sustain some kind of life, but not the type of life that we know from our Earth. Why does only one planet have a ring? So interestingly, all of the gas giants do have rings. So Jupiter has a ring, Saturn has rings, Uranus and Neptune both have rings. The thing is that Saturn's just got the best ones. That Saturn's got the biggest, the brightest, and the easiest to see. So that's why we often think of Saturn as being the ringed planets. And the reason that those rings occur was probably a moon got a bit too close to Saturn or one of these other planets and just sort of got ripped apart and ended up still hanging out around the planet. So why do we call our moon the moon? So the moon's technical name, like from the old Greek or Roman, is Luna, and the Earth's name is Terra. But we don't really use those anymore. We call the Earth, and we call the moon the moon. It can be quite confusing when you're reading academic papers about the moon and you're like, there's a moon. Are they talking about the moon or are they talking about a moon? So that can be a little bit confusing. So someone has asked about Pluto. So I'm just going to, I've got a backup slide about Pluto because lots of people often want to know about Pluto. Where is it? All right. So what makes a planet a planet? So Pluto is a dwarf planet and not a planet. So the reason that it is a dwarf planet is that in 2006, the International Astronomical Union, the thing is they were finding so many other planets out near, so many other things out near Pluto that were of similar size to Pluto, that it was going to start getting very, very complicated if they have to use all of these different objects and give them all proper names and make us learn all the different planets of the solar system. They weren't going to be 9, they were going to be 13, and it was just going to get messy. So what they did was they decided to rearrange the rules of what it means to be a planet. So there's 3 rules to be a planet. The first is that you have to orbit a star, right? So you have to, if this is a star, you have to go around it. That's fine. Pluto does that. That's all good. You need to be spherical. So under your own gravity, you need to be a sphere. So you need to be a ball. You can't be a weird potato. So you can't be like my glasses case here. That's not a ball, right? We need something that is going to be a ball. I'm just trying to see if I have any here, and I do not. And the final thing is you need to be the biggest thing in your orbit. You need to have cleared your orbit of all the other stuff. This is where poor little Pluto doesn't quite cut the mustard, right? Pluto crosses over Neptune's orbit. So Neptune is bigger than Pluto, right? Neptune is going to win that fight if it comes down to it. It's not, because Pluto and Neptune are in resonance, so that's fine. But so that means they'll never run into each other. But, you know, Neptune's a lot bigger than Pluto, so that's where Pluto sort of fell down. So Pluto's not shrinking, it's just that it got renamed as a dwarf, reclassified. It just makes things easier for scientists so that we don't have to call everything that is spherical in space a planet, because then, well, stars aren't planets, they're stars. So it just makes it a little bit easier on us. All right. Moons. So someone's asked, how do moons of moons form? They're probably either, so this is something that's sort of theoretical. I don't know if we've seen it yet, but you can get what we call moons. So they're a moon that goes around a moon. So they're just, it's a bit of a mess. They've probably been either captured or they're remnants of when that moon formed. So what would happen if we could get to Europa, what would happen if we break the ice? So if we broke the ice on Europa, so actually on Europa, the ice cracks open by itself quite often. It just sort of cracks open, water comes up, seals the gap. That's how we know there's water underneath it, because it constantly cracks itself open, water rushes up and fills the gap, and then it freezes again. So someone has asked, how does fusion start in a forming star? Basically, the gravity gets so strong and the star gets so heavy, massive, there's so much mass there. It's all pushing in, it's pushing in, it's pushing in. There's so much pressure in the middle that the atoms start fusing together. So someone has asked what is a red giant, and someone else asked earlier what is a black hole. So the reason I'm putting those together is they're things that happen to stars near the end of their lives. So as a star evolves and runs out of fuel, it will become a red giant. So basically the inside has given up, it stopped having fusion, but just outside it, there's still some fusion happening outside the core. And now it'll puff up, all those layers will puff up and it'll become a lot bigger and it'll be a red giant. So it turns kind of red because it cools down. Now that's what our sun's going to do. It's going to become a red giant. And then once it's sort of gone through that, it will end up as a white dwarf. So it'll just sort of be a hot little ball of not much. Now a star that's bigger than the sun, much bigger, might become a red giant. And then when it collapses at the end of its life, it might make either a neutron star or a black hole. Now, neutron stars are very, very, very dense objects. They can weigh, they're about, 10 kilometers in size and weigh a whole star. So they're extremely dense material. And how long someone's asked, or it could become a black hole if it was even heavier. Someone's asked, how long do black holes last? As far as I know, forever. They last forever, and black holes can merge with other black holes and become a bigger black hole. So yeah, black holes are a very interesting situation. Sorry, I'm just reading your questions. They're popping up for me, so I'm just someone asked how big the storm on Jupiter is. It's quite big. I think you can fit a good many Earths in there. It's much bigger than the Earth. It's quite big. It is getting slightly smaller though at the moment, because we've been able to see the great red spot on Jupiter, the storm. So let me just find a picture of Jupiter. Jupiter. So this spot on Jupiter, the great red spot, we've been able to see that for hundreds of years since we've had telescopes. And it is slowly getting smaller. So, but it is still bigger than the Earth. It's quite big. What does the Earth orbit? The Earth orbits the sun. Well, actually, interestingly, I've got an interesting one for all of you. All things that orbit, so let's consider Jupiter and the sun. Now, Jupiter and the sun Jupiter's quite big. Jupiter is, well, it's 1,000th of the mass of the sun. So it's still it's a lot smaller than the sun, but still quite big. But when things orbit each other, you can think of it as if you sort of spin around holding hands with your friend, right? One of you doesn't necessarily spin around the other. You spin around your hands if you're both about the same size. But if you think about a seesaw, and if you put a child on one end and an adult on the other, the child goes up usually, right? So if we've got something small and light on one end and something bigger and heavier on the other end, we end up with this, right? You end up with the star being a lot heavier than the planet. So you need to move it so that it balances. So you can try this out actually at home with a spoon. if you try and find the balance point of where the spoon balances, it's closer to the spoon end of the spoon than it is to the handle end. And this means you found its center of mass. So when planets orbit stars, they actually orbit a point between them called the center of mass. Now, for Earth, with the sun, the center of mass is inside the sun because the sun's very heavy. Whereas for Jupiter, it's actually just outside the sun. And this is handy for astronomers because that means we can find exoplanets, which are planets that orbit other stars. So you can see the star wobbling and you can be like, oh, there's something heavy pulling on that star. It's probably a planet. Sorry, I'm just, each time I finish a certain round of questions, I'm just sort of getting back to them to make sure I answer them. There was one that asked, what does this Earth orbit? And the Earth orbits the sun. Oh, that's what I'm answering, right? What is the difference between the sun and a red star? So the sun's temperature color is, so the sun's sort of a yellow star. So if the sun was a red star, it would look redder rather than looking yellowy white. There's also stars that are hotter than the sun. So red stars are cooler than the sun, and stars that are hotter than the sun look more white, or they might even look blue. Are there any planets that orbit a black hole? Now, I'm not 100% sure if there are, but the first planet that we discovered around another star was actually around a pulsar, which is a neutron star. So we do find planets around these sort of dead stars. So that's pretty exciting and pretty interesting. Whether they formed there or they're there from before the star died, that's also an interesting concept. How would it affect humankind if the sun were to become a red giant? Well, it's not going to happen for 5 billion years, so you know we've got plenty of time. The edge of the sun would probably come to Venus. It might even come to Earth. It would make the Earth a lot hotter. So we'd really have to do something about that. I don't think humans would have a very good time if the sun were to become a red giant anytime soon, but it's not going to. We've got 5 billion years, so you don't need to worry about that right now. Is there a new planet? There are new planets all the time. So we find what we call exoplanets. So these are planets that orbit other stars, so stars that aren't our sun. And we're finding those all the time. I think there's a talk next week specifically about exoplanets, so and planets that we find in other solar systems. So that might be interesting. Or what does mass mean? That's a very important one. Sorry, I keep saying it. Good point pulling me up on that. It's how heavy something is. It's kind of like weight. So your weight on Earth happens because of our gravity as well. So mass is just sort of a way of saying weight, but that doesn't depend on gravity. Sorry, I'm just reading your questions again. What would happen if the moon was 10 times larger than it is? We'd get some very strange tides, I think, because the moon does affect our tides and has a sort of, it pulls on the Earth's water. We'd have some, I don't know if we'd have a very good time. It would be very, very, very bright in the sky. Yeah, but it would do interesting things to the tides. So I'm not sure that would be best for humans. I think the moon's a good size. I think it should stay the size that it is. How did the red storm form on Jupiter? Look, I'm not 100% sure. I think it's kind of like a big cyclone that's just continuous. It's a big continuous cyclone. So someone's asked what chemicals we normally find in stars and if there's any that aren't on our periodic table. The answer to that is no. They're all the ones that we find that we know of. So and also we only know how to find the ones that we know of. But in stars, the most common things you see are hydrogen and helium, because that's pretty much what most of the universe is made of. Most of the universe is made of hydrogen and helium. Is the sun spinning? So the sun does rotate. It rotates on, I think, a period of a few days, just sort of rotates slowly. So you know how we have days on the Earth? The Earth rotates. So it rotates this way as well as rotating around. So it's, here's my hand sanitizer. It rotates this way as well as rotating around the sun. So we've got our days and we've got our year. So the same thing does happen for the sun. It does spin a little bit. What's inside Pluto? Pluto is pretty interesting, actually. It's made of nitrogen. So that's something that we actually have a lot of in our atmosphere. What else is inside Pluto? Nitrogen. It's got lots of organic molecules, actually. There's probably some dust inside it, but it's mostly made of different kinds of ices. Ice like ammonia or carbon dioxide or all those sorts of things. Sorry, someone's asked about one of the moons of Jupiter again, so I'm just getting that back. Ganymede. Okay, so yeah, so the from Jupiter, we've got Io, Europa, Callisto, Ganymede, and Callisto. So these moons look kind of rough because they get hit by stuff. You know, when you look at our moon looks rough because it's been hit by little meteorites or all sorts of stuff, and that just puts craters. And because if they don't have an atmosphere or a water cycle like we do on Earth, you don't get that same kind of erosion. So you don't get the hole getting filled in with dirt. You just end up with it being you end up with craters everywhere, so you can actually see them. And that's one of the ways that we tell how old some of these things are. We count the number of craters. So someone's asked about brightness of stars. So they've asked, is the sun the brightest star? Now, this is a tricky thing. So the sun looks bright to us because it's close to us, right? And that's what astronomers call its apparent magnitude. But if you put the sun at a certain distance from us, it would look quite faint. So there are stars that we know that are brighter than the sun, but the thing is that from their absolute brightness, but because the sun's closest to us, it looks bigger and it looks brighter. So someone asked what will happen when the universe ends and what will happen if the universe explodes. So I'm going to answer both of those together. So I'm going to preface this with, this isn't my particular field of astronomy, but the universe is expanding and its expansion is accelerating. So it's getting bigger, and the more it gets bigger, the faster it goes. Now, this was that discovery won the Nobel Prize in 2011 for Brian Schmidt, who is the Vice Chancellor of the Australian National University. Basically, when the universe ends, there's a couple of ways it might end, and we don't know how it's going to end. It depends on what shape the universe is. Sorry, let me just get my brain. I'm getting distracted by new questions that are popping up. Universe expanding. Yes. So we don't actually know how it's going to end. Someone asked, will the universe explode? We don't know. How will the universe end? We don't know. There's a couple of different options. And so if you're interested in those, hopefully someone might talk about them in the coming weeks. But I'm just going to keep answering I'll answer about 3 or 4 more questions. So I don't know. So someone's asked the sun's rotational period. I don't know that off the top of my head. I think it's a few days, maybe 11 or 12 days. But I might not have that number totally correct. However, the Wikipedia page about the sun will definitely tell you. Um, why do moons look like planets? They look like planets because they're basically small planets. That's why they look like planets. They're basically planets that didn't quite get big enough to be their own planet. And the only reason they're not planets is, or dwarf planets, is because they go around something a bit bigger than them. So they go around a bigger planet, so that makes them a moon. And when a star dies, does it always end up with one black hole or one neutron star? No. So it depends on what size the star is. So if the star's like our sun, when it dies, it'll make a white dwarf. That's how the sun will end. Now, if it is bigger than the sun, I think up to 8 times as heavy as the sun, it will make a neutron star. And if it's bigger than that, it'll make a black hole. So what you end up with at the end depends on how big your star was to start with. And I think I've covered most of them. Someone's asked me what's my favorite animal in the whole wide world. And for me, that is I probably like dogs the best, although I am quite partial to unicorns, even though I know the unicorns are a mythical creature. So I'll probably have to say dogs. But I think I've answered most of your questions, and I'm very sorry if I haven't. There have been some very fabulous questions. And I hope that if you are interested, you keep watching these videos that we're putting together, or these presentations that we're putting together for you. And if I haven't been able to manage to answer your question, some of them, if you are particularly interested in certain objects, like if you're particularly interested in Jupiter or Callisto or the sun, there are probably some good resources on the NASA website, so on the NASA page, and in other places on the internet that you might be able to look those specific numbers and things up that I can't remember off the top of my head. So I would like to thank you for watching and listening, and for all of your fabulous questions. You've asked some really good questions today, and I've really enjoyed talking to you, almost with you giving me your questions. Yeah, and I would just like to thank you and say goodbye. This will be available still on the Facebook page, this video. You can watch it back. Or, you know, if you didn't get a chance to watch all of it, you can watch the start, and we will be putting it up on our Facebook page. Not our Facebook page. We will be putting it up on our website in the coming weeks or sometime soon. So, yes, thank you very much for joining me today.